Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. And today, we are going to talk about how we can do programming with AWS IoT Device Shadow Service. So let's understand what is Device Shadow Service in IoT. So when you have any device which you have registered as a thing inside AWS IoT core, you can use device shadow to maintain device state. So for instance, if you are using any end device which has state like temperature or vibration or pressure or any kind of or humidity around the device. So these devices maintain some of their own state. These devices measure some of these states around them, and then these states of the devices can be maintained inside device state. And this device state is in the format of the JSON document, and I will talk about that later. Now, this device state can then be maintained by various parties. So, for instance, device itself can maintain the state, telling the temperature, pressure, or humidity around it. Then you can build applications which can maintain the device state. And generally, applications or services change the device if they want device to change their state to something specific. And devices maintain or update the device state if they want to report back these applications and services about the device state. So I'm going to show you a very small example how it works, and then it will make more sense to you. But so far, understand it in a way that when you have a device deployed and they are registered as a thing inside AWS IoT core, each of these devices can maintain device shadow, which is nothing but a device state or the information which device want to maintain as a state. And this is in the JSON document format. And this device state can then be updated by either device itself or through some kind of application or services. So let's see how does the device state look like. So it's very much free flow format, but a few things are mandatory. So for instance, you need to have this state element over there. Then generally people have two subfields or subnodes. One is desired and the reported. And desired is when some application is telling device that, hey, you should be changing the temperature to say 70 degree or things like that. If you want device to move to certain desired state, then you put that into your desired attribute. And the reported is what device reports back, saying that, okay, my temperature right now is say 70 degree. So things like that. So the purpose of keeping these two separate fields, desired and reported, is the desired when your application is telling device to change status to certain desired state, and reported is what device reports back to the as an actual state on the field. Generally, the purpose is that reported should match to the desired state, because desired is what the state or desired should be. And then desired value is something device reads, changes the status to the state to the desired state, and then reports back to the shadow that, hey, I have changed my status to the following. Again, I'm going to show you example, and then it will start making perfect sense to you. But generally, this is a typical structure of how the state document look like, shadow state document look like. So let's take it through an example. So and then it will perfectly make sense to you. And suppose on the left-hand side you have got a device which is some home thermostat, okay, and then it has been registered as a thing inside AWS IoT core, and it is maintaining a blank shadow. That means there is no shadow, there is no state so far. And then this shadow is something which one application also interacts with, and this application has got some thermostat app which it will use to work with the device shadow. So suppose you deployed the device, and right now, yeah, everything is blank. There is no state. Now, what happens is that this application says that, hey, I want my house temperature to be 70 degrees. So it will go ahead and update the device state in the shadow document saying that, hey, my state desired temperature 70 degrees. Now, when it happens, the device will get notification about a new shadow document, a new shadow state. And what it will do that it will read the new shadow document, it will change the temperature to 70 degree, and it will report back that, okay, fair enough, I have changed my temperature to 70 degree, your desired state was 70 degree, my reported state is also 70 degree. So far, so good. And anytime application can go and check the state and say, okay, fine, I asked the device to go to the 70 degree, and the device has reported back that it is at 70 degree. Now, you might change your mind some point of time later and say, okay, fine, I want to change my temperature to 60 degree now. So you go and update your state and say, I want to change my desired state to now 60 degree, while your reported state is still 70 degree, and that is fine. Again, when you go and when the application is updating this state, then what happens is that a device gets a notification about it and said, oh, I see a new desired state. It will go and change temperature to 60 degree, come back and say, hey, my reported state is now 60 degree. And again, yeah, you know that your device is at the same state what you asked it to be. Now, many times these devices are using house Wi-Fi at the home, which are sometime, yeah, you can't guarantee it will always be available. Devices can go offline, the Wi-Fi's can go offline. So there could be a scenario where this device suddenly goes offline. And here comes the beautiful part. So suppose the device goes offline, and then your application, meanwhile, yeah, you said, okay, now I changed my mind again, okay, and I want my desired state to 65 degree. Now, you ask desired state to 65 degree, but device is offline. That means it cannot get notification that device shadow has now changed to 65 degree. But here is the beautiful part. Since this state is stored inside IoT Shadow as the latest state, when the device comes online, it can fetch, and generally that's what you build into your device framework, that okay, when the device comes online from offline to online, it will fetch, give me the latest shadow document or state document, and says, oh, meanwhile, and if it's suppose 60 degree, then device is okay, fine, I don't need to do anything. I'm already at 60 degree and the desired state is 60 degree. But here in this case, the desired state is 65 degree. So what it will do is that it will change temperature to 65 degree and report back that, hey, the status has been changed to 65 degree. So even if since your mobile application is not talking to device directly, and though you can talk through MQTT like that, but since in this case we are maintaining the state into intermediate IoT Shadow service, what happens is that even if a device goes offline, you can still pass some command for the device, and when device comes online, it can take the latest command and can work. So it supports even those devices as well, where devices can go offline due to network connectivity, or if they have nature of being getting offline online, and just to state, say, battery life and those kind of things. So that's how the device shadow works. Okay, through an example. Now, how does this whole communication works? Let's get a summary of that, and then I will come to the point. What we are going to build today. So when you're talking about your device to your IoT Shadow communication, generally this communication happens through MQTT protocol. Devices use X509 certificates for the authentication, and they use MQTT protocol to talk to device shadow service. And for that, they use IoT device SDK for the programming purposes. When you want your applications to talk to IoT Shadow service, in that case, generally you will use IoT Data SDK. So you're not using device SDK anymore because we're not using MQTT. We can simply use API call. And for that, you can use IoT Data SDK. And then again, you try to implement some kind of custom authentication because like in case of device, you have got X509 certificate for the authentication. Well, if you want your app to authenticate, you can still use X509 certificate, but in that case, you have to use MQTT protocol. But if you're trying to make an API call, then actually you can use any custom authentication, and custom authentication could be any kind of authentication using Amazon Cognito service where you authenticate and then you impersonate a role, and that role will have permission to talk to IoT device service. So you can use method like that. Now, in one of my earlier workshops and videos, I have already talked about how your MQTT and IoT device SDK works. So that means your device to IoT Shadow service I have already covered into some of the other workshop I have published earlier. Today, we are going to talk about how you can build an application which can talk to IoT device service using IoT SDK, IoT Data SDK APIs. Okay. So what are we going to build today? So what we are going to build today is pretty straightforward. We will go and build an application in Microsoft C#. In this case, I use C#, but you can use any other programming language of choice, whether you want to write in Java or Python or any other supported language. But in this case, we use C# because one of my actually audience actually he asked that can you show me this communication with Microsoft Windows and C#. So I said, okay, fine, let me build something which is specific to his need. So yeah, we are building a C# application over here, which is talking to IoT device, IoT Shadow service using IoT Data SDK. And for authentication, I'm keeping it very simple. I'm using IAM user authentication. But what you can do is that you can also use services like AWS Cognito to implement any kinds of custom authentication, or you can use any kind of federated authentication as well. So this is what we are going to build today. So let's start doing it. So first we go to, our AWS console, and there I have created this Dozo user. Is one of the user account, and this user account I'm going to use for authenticating to the IoT device service. So I have simply created a Dozo user account, and I have generated an access key and secret key, which I'm going to use for authentication. Now, this one has got access. So this one has got enough permission. Right now, I gave it like administrative access permission, so it has all the permissions. But basically, if you're building a real application, then you might want to restrict the permission to only IoT device shadow service only. Okay, so only IoT related applications. So this is the user account I'm going to authenticate using access ID and secret key. Now let's start with the first step. I'm going to first go and create a device. So let's go to things, and I want to register a thing and say create a single thing. And this one I say this is Dojo device. And then I don't want to do any other configuration here. So next, and then you can generate a certificate, and you generally create a certificate if you want to use MQTT based authentication, and you want to have X509 certificate created so that it can be used for authentication. But in this case, since I'm doing only API call based authentication, I really don't need a certificate. But anyway, I mean, I'm bypassing this step, but you can anyway later create a certificate and attach it to the device. So let's create a thing without a certificate. So my device is ready. Now, if I go and see the device, a few things I have to make note of. The first one is that, I need to go to the interact, and this is the device gateway endpoint. So this I have to make note of. So I'm just doing copy paste of this URL, and then if you go to the shadows over here, you can see now. Device has started supporting actually multiple shadows. Earlier used to be only one shadow. I will cover this some point of time later. If time permits, I can do it in the end of the session as well. But you have this default classical shadow already there. You can see here. And then right now it has got a sample shadow over here. And this is the name of the shadow document. So I simply copy paste this one as well. Great. So all good. So what we have done so far is that we have registered a device. So I have registered a device over here, and then I have an IAM user which I can use for authentication for API call. Now it is time we start building the application. So now I'm going to build the application. So I go to the Microsoft Visual Studio where I have built a C# application. This is a sample application I have got ready. Only the UI part, there is no code behind it. And then it has got three methods: one to get the shadow, one to update the shadow, and one to delete the shadow. So let's start working on this. If you're working on a Visual Studio, then you have to configure the AWS profile first. So let's do that. So I go to the view and say AWS Explorer, and there I'm going to create a new profile. And this profile I call Dozo user profile. And then I need to provide my access key and secret key. So my access key and secret key I've already copied in another window. I can simply copy paste from there. So I provide my access ID, and this is my secret key. Okay, fair enough, and save it. So now my profile has been created. You can see it has oops, it's taking some time to save. Okay, Visual Studio. Okay, so my Dozo user profile has now been created. So having this part done, now here is my Windows application. It has an app.config file here where I need to configure this profile. So I'm going to do some copy paste here, and this is very much publicly available, and I'm going to provide this code base in the attachment to the channel so that you can also copy and download it. So what we do here is that we add the settings where say my AWS profile is Dozo user profile, which is the one we created over here, and the region I'm working is EU West 1, which is the Ireland region. So that's where I created my the device. So with this, my configuration is ready for the authentication. Let's add the module for IoT. So if I go to the manage NuGet package manager and say I want to, I'm interested in AWS IoT, and in AWS IoT, I'm interested in IoT data. Okay, so I'm using this IoT Data SDK. I'll confirm it. And now AWS SDK.IoTData is available to me now. So let's close this one. This one, so far so good. So now having said that, let's do and start churning some code. First, I will go and import the module. So if I go on the top here, a few things I want to import. So say using Amazon IoT data, and then using Amazon IoT data model, and finally using system.io. Fair enough. I need this one to parse my input and output. So I did this. And then I will go ahead and update some of these URLs over here. So this is the device name. So if you remember, the device name was Dojo device. So this we are going to use in our coding many places. What is my device endpoint? In fact, I can close this window here. My device endpoint is, if you remember, I made note of that in my configuration. So it's HTTPS, and this was the device this was the in fact IoT endpoint. And finally, what is the shadow document name? And I make note of the shadow document name as well. So here goes my shadow document name. So let's save this thing. So all I have done here is that provided a device name, device endpoint, and device shadow name. So after this, we can actually start writing the code. So right now, if you go back to the device shadow, you can see that in the shadow, I have got this this shadow here, which I don't like, actually, to be honest. This is not the right shadow, so I want to delete it. So I will start with the delete operation first. So if I go back to my code again here, if go to my designer, okay, and I want to delete the shadow. So let's write the code for the delete. So what I will do here, I will do some client. So I'll go say Amazon IoT Data client, okay. I will simply initiate it, client, and then it takes a parameter called device. Device client. Sorry, I think I'm doing some mistake here. Let me, okay, let's try it over here. And then, yes, client equal to, yeah. So I'm initiating my Amazon IoT data client over here, which needs one parameter called device endpoint. Okay, having done that, now let's write the delete code. So here I'm going to say this is my delete thing shadow request. Say request equal to delete shadow request. I'm trying to create a request document for the delete operation, and then it will take certain parameters. So for instance, it will take what is the shadow name, and my shadow name is device shadow name, which I've already provided there, and then I say rec dot what is the thing name, and that is your device name. Okay, and after that, I can simply call the client dot delete shadow thing method and pass this request as one of the parameter to it. So when I do this, actually, I think we are good now. If I go and rebuild it, so far so good. Hopefully, so I simply go ahead and then run this. In fact, let's do a confirmation here, saying that message box dot show shadow deleted, and then run it. So when I go and run this application, so I have provided code for this button over here. If you click on delete shadow, it says shadow has been deleted. So let's close the application and let's verify it. So if I go to my device shadow again, okay, probably have to refresh it. Okay, sometime refreshing can take time. If I go load here and go to shadow, you can see there's no shadow found. So earlier there was a shadow, but that shadow has now been deleted. So it is time we go ahead and create a new shadow document here. So for that, we'll go back to our code and we will implement this update shadow service. So to do so, we'll create an update shadow request. So update thing shadow request rec again shadow request, and then I'm saying that rec dot thing name is your device name, and then rec dot shadow name is your device name, and finally rec dot your payload. Okay, and this payload in this case, guys, it takes a memory stream. So in this case, I'm going to create a new memory stream document. So payload is taken in the format of the stream. So I'm going to create a new memory stream. I will encode it. So and yeah, encoding dot UTF-8 dot get bytes, and then here is my document, and document I'm going to provide into this field called txt shadow document dot text. Okay, so if you see here, this is my txt shadow document dot text control, and I'm simply going to read text from there and converting it to memory stream and providing to the payload. And at this point of time, I can simply go and say here client dot update shadow thing, and then provide this rec as a parameter, and then simply confirm a message box saying that the shadow is updated. Okay, so having done that, if you run this code, you can see I can simply click on this button that will run this particular line of the code here. If I say do upload shadow, it shows me errors and that remote server and bad request. So let me see what's going on here. Oh yeah, I did not provide the shadow document here. So let's start again. Let me provide the shadow document here. And in shadow document, I'm saying that okay, device, I want you to maintain a desired state, and desired state is that temperature equal to 10 degrees centigrade, for instance. And say, let's update the shadow. And I get confirmation that my shadow has been updated. Now, if I stop the application and go back to my shadow document again, if I go ahead, open the device again, and then see my shadow document, you can see a device shadow here. If I open this one, you can see here that it says that my temperature is 10 degree. And since my earlier shadow was nothing, so it says the delta, means change in my shadow is presented by delta, and that change is that temperature equal to 10 degrees. So this is the change, because earlier my shadow was null. Now I'm saying my shadow is desired temperature equal to 10 degrees, so it captured my delta as well. So far so good. It is able to create my capture my shadow. Now the next step is to go and fetch this shadow, and for that I will write the code inside my get shadow method. So what we do over here is that we write the next line of code, and that code is that we want to actually get the thing shadow. So for that we make a request, say get thing shadow request rec equal to request. Again, the same pattern, rec dot your shadow name equal to device. Oops, device device shadow name, and then rec dot thing name equal to device device name, and then we simply say in this case get thing shadow response equal to client dot get thing shadow, and then path is request. Okay, and then I can simply read payload from the response, but that is in the stream format, to have to convert into string. So I say stream reader equal to new stream reader, and then I can put this response dot payload, which is in the string format, and then txt shadow document dot text, In that, I simply populate the response. So I got response reader dot read to the end. Here we go. So we do that, and then we run this code again. So pretty straightforward code, guys. Make a request, provide properties, shadow thing, get thing shadow method call, and then payload comes back in the form of stream, which convert into string, and simply populate to my text control. So if I run this code here, then it will, you can click on this one. It simply fetches, oops, and again it says remote server not found. Okay. So what is happening here? Okay, so I said device shadow name. Okay, looks like device shadow name is something else. I need to check that. So this, oh, okay, fair enough. So actually when I updated the device, it changed the shadow name. So that's something to be careful. So I need to go here and change. So yeah, just to share you guys what's happening. That so if you think here, if you go to the thing, this is my shadow, and this was my device shadow. And then here, when I deleted the shadow and created again, it generated a name in a different way. So this is what name it generated. So I'm going to simply update my shadow name with this, and we should be good after that. So I need to stop it actually. Yeah, and I update this. And then I run again and get shadow, and it throws error again. Okay, something is not working here. I need to see what. So device shadow name, shadow name I provided here. Okay, what's going wrong here? So okay, then let's go back and see one more time. So see, we can fix it. Okay. Okay, looks like I can provide my device shadow name like this only. Let's see. I think I'm making that mistake here. Okay, so let's do this one more time. And we run the code and get shadow. Oh, here we go. So yeah, so when you're using so that's the kind of learning for me as well, guys. So when it shows here the classical, that in that case you have to provide the shadow name in a classical way, like here the ARN you see here. But if you are creating a new shadow document, then in that case, you simply need to provide that shadow document, this shadow document over here, and that is more than enough to make it working. So you can see here we run the code and we have got the device shadow back. Now let's go and create one more device, because one device can maintain more than one shadow. So let's add one more device, and this one I say my other shadow. Okay, so I added, now this was my earlier shadow I created some other shadow just in case if device want to maintain different types of shadow. It's very complex, this device, and you don't want to keep every shadow together. So if you can go and see over here, actually you will find that the other shadow has been created, and it has got default shadow. Again, we can go and delete it, but just I want to show you that suppose if you want to capture the play with the other shadow, all you have to do is simply go and change the shadow name. If I go back to my code, simply save it over here, and then if we run it, and in this case, suppose I want to get again, you can see that it has fetched my device shadow from the new shadow. So that was all for today, guys. We just wanted to show you how you can build application, using IoT as Data SDK to work with device shadow, to update it, to get it, to delete it, And whenever you are building you're deploying your devices, and you need to configure your devices, whether you want to fetch the device state or you want to update the device state, that in that case it is very important to build the application which can talk to device shadow, and through device shadow you can instruct your device to follow certain configuration to maintain certain desired state. And this was an example using Microsoft C# programming language and IoT Data SDK, how you can achieve it. Similar kind of programming you can do with other languages as well. Okay, like Python or Java as well. If you are interested to know about how we program in those languages, I'm happy to make another video or share some code snippet related to how to program in those languages. So that was all for today, guys. Hope you enjoyed the video, and if you like the video, please click on the like button. Please subscribe to my channel. I really need some good encouragement from your side. And we keep providing this kind of demo scenarios, workshop, and exercises to our website, aws-dojo.com. Yeah, I am going to provide you a link of our website to the description box below. Yeah, feel free to reach out to our website, see the workshop scenarios, and follow the instructions to implement this kind of use cases and learn about AWS services. So that was all for today. Thank you very much for your time, and talk to you again soon. Bye-bye.